Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 2, Growing Dots. Today our learning focus is describing a growing pattern with tables, graphs, and equations. So how does the pattern change from one figure to the next? How can I use a mathematical representation to show how I see a pattern? So let's take a look at our first one. Mark the way you see the pattern growing in the sequence of the figures given. Okay, so I see 1 in the center. Let's see, I'm going to go ahead and get a drawing tool here. So at the beginning, which is my 0, I have 1. 1 minute, I have 5. 2 minutes, I have 5, 6, 7, 8, 9. Okay, so I'm noticing that we kind of get, there's 1 in the center. Here's my center 1 every time. And then I grow the 4 on the outside there. And the next time I'm growing 4 more on the outside. So it looks like I'm growing 4 each time. So if I were to go to 3 minutes, plus 4 would be 13. And that means I'd have my 1 in the center. I'd have my 4 from this one. I'd have another layer of 4 going there, and then I'd have 1 more. So there we go. So 13. How many dots are there at 100 minutes? Well, let's see if I can kind of figure this out. I always have 1 to start with, and I have 1 set of 4. So I'm going to just write out my pattern. At 0, I have 1. At 1, I have that same 1 plus 4. At 2, I have the 1 plus 4 plus 4. And at 3, I have my 1 in the middle plus the 4 from the first, the 4 from the second, and the 4 from the third. So what I'm noticing here is that 1 4 on my first one, 2 4s on my second one, 3 4s on my third one. So how I'm going to put that on here, my term number, my minutes, I guess, 1 minute, I multiply 1 4. 2 minutes, I have 2 4s multiplied plus 1. 3 4s multiplied plus 1. So that means if I substitute in my 100 minutes, I'm going to have 4 times 100. So I'm going to have 100 sets of 4 over here, plus 1, which equals 401. It's kind of my thought process on there. How many dots are there at t minutes? Model the pattern using a table, graph, and an equation. Your model should indicate how many dots there will be at the 3-minute mark, 100 minutes, and t minutes. So I need to make sure that I go all the way up to 400, right? So let's see how many. Do my graph just like this. I'm going to go ahead and draw my lines across here. Actually, you know what? Let me undo that. And actually, let's do that in black. Let's do my graph lines. I know these all are going to be positive. So I'm going to do that. I actually already figured out my equation above, didn't I? 4n plus 1. 4 times however many minutes I was using, and then I had my 1 in the middle each time. So that's my equation, equals, we'll do t for total. So now for the table. Okay, so I have my minutes, and then dots. So I actually should probably, let's change my variables. So we're going to say my dots equal 4 minutes plus 1. Okay. So first minute. 0, I had 1. 1, I had 5. 2, I had 9. 3, I had 13. And 100, I had 401. So that's kind of big jumps in there, isn't it? So let's see. If I go 10, 20, 30, 40, 50, 60, 70, 80, doesn't quite get me to 100, doesn't it? I guess we'll just go by ones. Or 10, 20, 30, 40. That's 20, 40, 60, 80, 100. Not quite using my whole chart, but best we can do at the moment. So let's see what I have to go by over here to be able to do this. So at 20, let's go ahead and do this. 20 times 4 is 80, so that's 81. And then I need to get to 401. 10, 20, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8. So let's count by 20, 40, 60, 80, 100. We only have to go, let's go 50, 100, 150, 200, 250, 300. This will be 400 up here, 350. So 20 is at about 81. So that's going to be 75 right about here. Oop, let's do a different color for my dots. Here, 40 is going to be 40 times 4 is 160 plus 1, so 161. So right about here, 60 would be 241 equals 241. So 60 equals 241. And 80 would be 321. 321. So that's just under the line right there. All right. And so I'm going to go ahead and connect these because we know there's a whole bunch in between there that we are missing. Oh, and the 100 was 401. Perfect, right there. Okay. So there we go. All right, so create a pattern dots that increases by 3 each minute, starting with t equals 0. So let's see. How can we do this? This is our ready for more on here. So I'm going to start with, we'll just start with 1. So at the first minute, or let's do the 0 again. So at 0, we have 1 dot. If it increases by 3, then let's just do a similar idea like this. So I have my 1 in the middle, and now I have 4. And so now my 2 and then this one's 7. Oh, starting with t equals 0. There you go. And so there we go. Now I need to write an equation that models it. So same idea as before. This time I'm adding 3 each time. So here's my, oh, I missed one over here. There's my original 3. Here's my new 3. So kind of in that same pattern I did before. 0 had 1. 1 had the 1 plus the 3. 2 had the 1 plus 3 plus 3. I'm noticing that same pattern. If I'd keep going, I bet there would be 3 3s I would add together. So that's going to make my equation 3t plus 1 for that. All right, so for my takeaways, the representations. The representations are as follows: table, graph, explicit equation, recursive equation. So we did not talk about the recursive quite yet, but we will be showing that one with here as well. Let's just show that on here. Let's do it on this guy. So we had our first term was 0, t equals 0. And then we took our current term was the previous term. Oh, wait, no, sorry. Let me go back. F of 0, did that backwards. We started with our 0 term, and the answer was 1. So if we scroll up here, this right here helps guide our first one. We started at 0, the answer was 1. So now I took my current one, was my previous, let's use different colors, my previous plus 3. So that's how those go together. All right. So for my table will show me, it shows the common difference. Shows the common difference between terms. Okay, my graph will then show my line with the slope. The explicit equation, oh, and in this case, let's do it to specifically our one up above. It was a plus, where's my plus? Plus 4. So we're going back to the original up there. And then our slope, m equals 4. So our slope was 4. So then our explicit equation was, we wrote it in terms of f of t, let's practice that function form, was 4t plus 1. We'll use it above. And so then the recursive would be the next term equaled the previous plus 4. And this is the notation, how you would write it before, but that's the idea. That's the idea behind it. All right. So now, when we're looking at these specifically, an arithmetic sequence is a sequence with a common difference between outputs. The recursive thinking relates one output to the next output. The recursive equation, our next equals previous plus 4 in this case. And our explicit equation is shown right here. They've already given us that one. And explicit thinking relates an input to an output. So, for example, f of 100 equals 4 times 100 plus 1, and that equals 401. We could do any number in there. So let's do a 3. So this time it was 4 times 3 plus 1, and that got us 13. So if f of x equals, we'll just say 2x minus 3, the explicit equation, I forgot the L, explicit equation is called a function rule. Because then, scroll down a little bit here, if we plug in something, so like f of 5, that's going to equal 2 times 5 this time, minus 3, which 2 times 5 is 10, minus 3 is 7. So we've kind of made a rule, a function rule for that. So that's pretty much the note as far as that goes. Let's go ahead and scroll down to the retrieval. I don't think there's anything on that one. Nope. Okay, so the retrieval. Identify the pattern in the table and fill in the missing values. Well, I don't know of anything that multiplies or divides to go, multiplies, I guess, to go from 28 to 37, but I think that is a plus 9, right? Yeah. So 37 plus 9, that would actually be 46. So I'm going to do the same thing here. 46 plus 9 would be 55. And 55 plus 9 would be 64. And 64 plus 9 would be 73. So I was able to fill that one in. Let's do the next one. This one, I noticed this looks like it is a times half, or divide by 2 times half. So half of 32 is 16. 3 half times half would be 8. Half of 8 is 4. All right, that one's done too. Next one. Here, if I do a 2, so I'm going to substitute the 2 in for x. Negative 4 times 2 plus 9 equals negative 8 plus 9 equals 1. So it's going to be 2 comma 1. Now we'll substitute in a negative 3. Negative 4 times negative 3 plus 9. Well, that's 12 plus 9 equals 21. So negative 3 comma 21. And my last one, I'll put in a 0. Negative 4 times 0 plus 9. 0 plus 9 equals 9. So it's 0 comma 9. All right. That's all we've got for the notes today. We will see you next time.